Welcome to the Explainer. Today, we're going to dive into this amazing invisible system that keeps airports from descending into total chaos. Seriously, there's this constant high-tech conversation happening between every single plane and the ground, and it's the only thing keeping everything running like clockwork. You know that scene at a busy airport? Giant planes taxiing everywhere? It looks like a crazy, chaotic dance. But believe it or not, there's a brilliant system behind it all, and it all boils down to a really smart, automated conversation. So how on earth does it work? Let's get into it. Okay, so here's our game plan. We're going to walk through 6 steps, starting with, the huge challenge of all these planes, then getting into how they actually talk, and finally, we'll see the amazing system that puts it all together for the folks in the tower. All right, section 1, the controlled chaos of airports. I mean, just picture it. The real headache for air traffic control isn't just the sky, it's the ground. How do you give them a perfect live picture of every single plane, every baggage cart, every vehicle, second by second? That's the real puzzle. Well, the whole system, this whole secret conversation, it all happens on one single radio frequency, 1090 megahertz. That's it. This one channel is where all the magic happens. It's the foundation for literally everything we're about to talk about. Okay, so if 1090 megahertz is the party line, who's actually talking on it? Well, the star of the show here is a little box on every single modern airplane called a transponder. You can think of it as the plane's own unique digital voice. And it's pretty simple, really. The ground system is basically shouting out, "Hey, who are you?" And the transponder automatically shoots back a reply like, "I'm flight 123 and here's where I am." The key thing here is that it's all automatic. The pilots don't have to lift a finger. But here's where it gets really smart. The old way of doing things was kind of like shouting, "Is anyone there?" into a packed stadium and having everyone yell back at once. Just a mess, right? But the modern system, called Mode S, think of the S as selective, is way smarter. It's like calling a friend by name. The system can say, "Hey, flight 456, what's your deal?" And only that one plane answers. It cuts through all the noise. Okay. But this is the really clever bit, the part that's absolutely critical for safety on the ground. How does a transponder know if it's flying high in the sky versus, just rolling along on the tarmac? It turns out there's a crucial bit of logic here, a big switch that changes everything about how it communicates. And you know what? It all boils down to a super simple physical switch. It's called air/ground logic. And usually it's just a little sensor on the landing gear. As soon as the plane's full weight is on those wheels, click. The switch flips and sends a signal to the transponder that basically says, "Hey, we've landed, we're on the ground." So check out this process. The second those wheels hit the runway, the plane's weight settles, that little switch gets flipped, and bam! The transponder instantly goes into what's called on-the-ground status. So what does that actually do? How does its behavior change? This is key. When it's in ground mode, the transponder doesn't just go silent, no way. It just gets, more polite. It changes how it talks to avoid jamming up the airwaves. And it does this in 2 main ways, either by answering a direct question or by sort of spontaneously broadcasting its own status updates. Okay, so the first way is that direct Q&A we were talking about before. A ground station asks a super specific question, that's the interrogation, and the plane's transponder shoots back a specific answer with its ID and all that. Simple enough. Now for the second type, and it has a kind of funny name, it's called a squitter. And a squitter is basically just a spontaneous broadcast. Think of it like a Facebook status update for a plane. It doesn't need to be asked, it just squits. It periodically broadcasts its info out to anyone who might be listening. And there are actually 2 main flavors of these squitters. You've got your basic acquisition squitter, which is really just a short, simple message. It's like the plane just waving and saying, "Hey, I'm here." Then you've got the extended squitter, and this one is the mother lode. It's a much bigger message packed with all the good stuff, precise location, velocity, you name it. This is really the heart of modern air traffic surveillance. Okay, so here's the big payoff. Remember that weight on wheels switch? Once that flips, the transponder stops answering those general all-call questions. It basically stops shouting into the crowded room, which is exactly what you want on a busy tarmac. But, and this is important, it never stops answering those direct roll call questions meant just for it. It's smart about when to speak up. And this isn't just some optional feature, by the way. This is a hard and fast rule from the big guys, the ICAO. They mandate this stuff to prevent what they call interference. Basically, to stop the airwaves from becoming a chaotic mess of signals. It makes sure that on the ground, the frequency stays nice and clear for the messages that really matter. All right, so let's put this together. The plane has landed, it's being smart about when it talks, and it's sending out these little squitter messages, these digital breadcrumbs of its location. So the big question is, how does the airport hoover up all that data and turn it into a live map for the controllers?
Well, the answer has a fancy name, multilateration. But the idea behind it is actually pretty cool. The beauty of this system is that it's totally passive. It doesn't broadcast anything, it doesn't ask questions, it just listens. It's got these electronic ears all over the airport just listening for those squitters.
And here's the really brilliant part, how it pinpoints a plane. So a plane sends out one of those squitters. Around the airport, you've got a bunch of receivers that all hear that same signal. But because they're in slightly different places, they hear it at very slightly different times. We're talking nanoseconds. The system measures this tiny time difference of arrival. It's almost exactly how your phone's GPS works, using satellites. By comparing those microscopic time delays from 3 or 4 receivers, the system can do some quick math and pinpoint that plane's exact location on the ground. It's incredibly precise. So when you pull all these threads together, the smart transponder, that little air/ground switch, the constant chatter of squitters, and the clever listening of the multilateration system, what you get is this amazing invisible safety net. It's this digital layer over the entire airport that, honestly, makes modern air travel as safe as it is. So let's just quickly run through that one more time. Transponders give each plane a voice. A simple switch puts them into a quieter ground mode after landing to cut down on noise. They keep sending out these little squitter broadcasts with their location. And a system called multilateration listens to all of it to create a perfect live map for the people in the tower. It's what turns that potential chaos into a beautifully choreographed dance. It really makes you think, doesn't it? The next time you're at an airport, looking out the window, just remember that silent, digital conversation happening every single second. It's a great reminder that some of the most important tech is the stuff you never even notice. Thanks for joining me on this explainer.